previous lecture, which was yesterday lecture, okay, we have learned until the subtopic of 1.6, okay, the mole concept and Avogadro's constant. And so far, okay, this is just to recap. We have learned that 1 mole of a substance is equal to Avogadro's constant, okay, which equal to 6.022 times 10 to the power of 23. That would be the first relationship that we have. And then secondly, we also have molar mass, okay? That means for 1 mole of a substance, the mass is equal to its atomic relative mass. Okay, the mass is for one mole of substance. And you have also learned that the mole of gases, okay, the molar volume, the volume for 1 mole of gases, okay, the volume of 1 mole of gases. Yeah, so please be aware of the condition. Okay, there are 2 conditions that you should know. One is at STP and the other one is at RTP. STP stands for standard temperature and pressure. The temperature is at 0 degrees Celsius and pressure is at 180 M. Okay, on the other hand, RTP is at 25 degrees Celsius and at 180 M. So the temperature are different for both conditions. Okay, and the value of molar volume there. Okay, so at STP should be 22.4 liter. Okay, 22. The unit is 22.4 liter per mole. Okay, that means for 1 mole of a substance, of a gas substance, is equal to 22.4 liter. Okay, that is for STP. For RTP, it will be 24 liter per mole, right? So if per mole, we can write it as this. Okay, that means for 1 mole. So 1 mole of gas substance is equal to 24 liter of volume. Okay, all right. So you have been introduced to that too. Okay, so we have several checkpoints that we haven't discussed during our lecture yesterday. And for today's lecture, somehow we still couldn't be able to discuss, okay, based on my previous lecture. I have lecture with S13 and S14 just now. Okay, we were not able to discuss the checkpoint somehow. Okay, so we may have to bring the checkpoint discussion during our next lecture. Okay, all right. So please complete all the checkpoints. Okay, we will discuss it next week lah. Okay, now let's move on to empirical and molecular formulae. Okay, all right. Don't worry, I'll discuss the checkpoint. Kita mesti discuss the checkpoint. Cuma the checkpoint can, is either will be discussed at that time or it will be postponed to another time. Okay, all right. So next will be empirical and molecular formulae, and this is also has been taught to you. Okay, you have been learning this in school. So I hope that this time around it gives you a better understanding on the topic. Okay, all right. So we have 1 learning objective. One is to determine the empirical formula and molecular formula of a compound based on its percent composition and from the combustion analysis data. Okay, all right. So composition by mass, this is just a revisit. Okay, you have learned this, like I said just now. The percentage by mass of an element is given by percent of element divided. Percent of element is equal to mass of element, okay, over mass of whole sample times with 100. Okay, so that will be our calculation on how to find the formula. Okay, on how to find the percent composition. Okay, percent composition of an element in a compound. Okay, all right. Okay, so there are steps that can be performed in order to determine the empirical formula of a compound. Okay, all right. The first step is assume the sample is in 100 gram. Okay, assume the sample is in 100 gram. Individual percentages become the actual masses. Okay, all right. So normally the percent composition, normally the unit is given in a form of gram. Okay, the unit is given in gram, but it can also be given in a form of percentage. Okay, take for example, if we have carbon, hydrogen, and oxygen. Okay, so carbon is 48%. Okay, hydrogen is 48 and then 12%. Okay, so oxygen is the remaining lah. Okay, oxygen will be the remaining because we are dealing with percentage. Okay, what we can do is we can just straight away convert this percentage into gram. So it will become 48 gram. Okay, 12% will become 12 gram. Okay, because we assume that 100% means 100 gram for 100 gram of sample. Okay, 100% represent 100 grams. So what we do is just simply convert the percentage into gram. We do not have to do any calculation in order to convert the 48% into gram. Okay, so it really save time. Okay, sometimes other student dia convert this given information into molar mass and then in order to convert into gram. Okay, take the molar mass of the carbon and then divide by the molar mass of the whole compound and then to get the what do we call that, the mass in gram. Okay, for each carbon, hydrogen, and oxygen. Example, okay. All right. Step number 2. Divide the mass of each element by its molar mass to obtain the number of mole. Okay. So next step is to convert the mass given into moles. Okay, for each of the constituent in the compound. Okay. Step number 3. Divide all numbers in the ratio. Divide all numbers in the ratio by the smallest number of mole. Give the smallest whole number ratios of each element. Okay, all right. So when you have calculated for the mole for each constituent, next, okay, you have to choose the least number of mole, okay, in order to divide each mole, okay, in order to get the ratio, the mole ratio. Okay, all right. So decide which one is the smallest number of mole, and then take that number, divide the mole for each constituent with the least number just now. Okay, all right. In order to get the whole number ratio. Step number 4. Okay, if the result of the ratio is within 0.1 of whole number, round to whole number. Okay, all right. Take for example, once you have divided with the smallest mole number, okay, you got 3.1 or less than 3.1 or 3.9. Okay, for example, okay, you can straight away convert this into 3. Okay, 3.9, you can convert this to the closest whole number, which is 4. Because it is within 0.1, okay, from the whole number, from the closest whole number. So we can just simply convert into the closest whole number. Okay, But if it is 3.25, for example, or 3.33 or 3.67, okay, you cannot just simply round off this value to the closest whole number. Let's say, for example, you jadikan 3. So this is wrong. Okay, 3.33, oh, the closer would be 3. No, it's not 3. Okay, you cannot just simply do that. Same goes to 3.67. It cannot be whole, it cannot be round off to 4. Cannot. Okay, so you have to consider for a factor, okay, that need to be multiplied in order to get the whole number. Okay, if you the ratio, okay, the number has 0.5, then you have to multiply all the ratio with 2. Okay, take for example one of the ratio ends up with 3.5. Okay, 3.5. That means you have to multiply all the ratio with 2. Okay, so let's say this is for carbon, hydrogen, and oxygen. So all need to be multiplied with a factor of 2, not only for carbon. Okay, if the ratio, okay, is 0.33 or 0.67 or almost equal to 0.33 or almost equal to 0.67, okay, you need to multiply with a factor of 3. Okay, and same goes to if you got 0.25 or 0.75, you need to multiply with 4 in order to get the closest whole number. Okay, alright, so these are the factors that you need to remember. Okay, kalau 0.33 we multiply with 4, then we wouldn't be able to get the closest at the whole number. Okay, that's why we need to multiply with 3. Okay, that's the reason how this factor came about. Okay, let's look at an example. Laboratory analysis of aspirin determine the following mass percent composition as follows. Okay, so the carbon, so aspirin consists of carbon, hydrogen, and oxygen. So the percent by mass is given 60%, 4.48%, 35.53%. So as you can see, they are all in percentage. Okay, so we can just convert them into gram. Okay, straight away convert into gram. So the question is asking for the empirical formula of aspirin. Okay, so use table. Okay, construct a table in order to find the empirical formula, because using table is more structured. Okay, we examiners prefer students to use table for your empirical formula calculation. Okay, all right, so you have elements, and then you have for the column you have all the constituents, okay, carbon, hydrogen, and oxygen. So the first row we have composition by mass in gram lah, okay, convert everything into gram. So 64.48, 35.53. Okay, and then next will be relative atomic mass. This is not compulsory. If you don't have this, it's also okay. Okay, not a problem. Because some of the constituents too, the molar mass is already we already memorized all of them, right? So why, let's just skip this part lah. If you feel that you want to include, then go ahead. Okay, all right. Next, find out the number of mole for each constituent. So this would be the moles. Okay, you have to divide the mass with the molar mass in order to get the mole. Okay, or you can okay. Mole ratios. Okay, next will be the mole ratio. You have to identify which of these constituents is having the least number of mole. In this case, it is oxygen. Okay, so use oxygen, okay, to divide with all the moles from other constituents. Okay, all right, so this is for carbon, and this is for hydrogen, and this is for oxygen itself. Okay, so 1 is not a problem. So you have to check for each one of the constituents punya mole ratio. Okay, 2.02 is also not a problem. It can be round off to the closest whole number because it is within 0.1, like we have learned just now. Okay, so it can be round off to 2. Okay, but for carbon, it cannot be round off to 2. Okay, you cannot just simply round off it to 2. So you need to multiply with a factor. In this case, with a factor of 4. Okay, when you multiply with a factor of 4, don't forget to multiply all the constituents with the same factor. Okay, it's not only applicable for carbon only. It's not only applicable for carbon. It is applicable for all the constituents present. Okay, all right. So these are the simplest ratio for each constituent. Okay, all right. And then don't forget to write the empirical formula. This is unfinished, guys. Do not leave your answer, the empirical formula, in this form. Okay, this table is just your working process in order to calculate for empirical formula. Okay, lastly, you have to make sure that you have this empirical formula written, C9H8O4. Without this, okay, you will be losing 1 mark for the final answer. Okay, all right. Okay, another example is the mass percent composition of an organic acid is given as, so again, we have carbon, hydrogen, and oxygen. So the mass percentage is given for each one of the constituents. And then, as you can see, we have extra information here. Okay, so when is this information will be used? Okay, look at the question. The question is also asking for a molecular formula. Okay, you need to find the empirical and also molecular formula. So this information may be used, okay, in order to find the molecular formula. Okay, all right. So now let's solve for empirical formula first. Okay, you have your table here and then your constituent. Okay, and then insert all the data given from the question. Find out the mole ratio. As you can see, all of them are having 1 as the mole ratio. Therefore, there is no need. Okay, there is no need to multiply with a factor. We can just use it straight away. Okay, all right. Don't forget to write the empirical formula. So we have here the empirical formula of the organic acid. Okay, so we are done with that. Next question is for the molecular formula. Okay, for the molecular formula, okay, the formula to find the molecular formula is, we have the empirical formula, right, in bracket, and then we have N, okay, is equal to molecular formula. Okay, right. Take for example, we have the empirical formula already. So CHO, okay, and then N is equal to molecular formula. All right, in order to find molecular formula, we need to find the value of N first. Okay, we need to find the value of N. So in order to find N, what is the formula used in order to find N? So this is the formula used. N is the ratio of molar mass of a compound, okay, with molar mass of empirical formula. Okay, N can be obtained by dividing molar mass of the compound with the molar mass of empirical formula. Molar mass of empirical formula is not a problem because we have the formula already. We can just simply total up all the molar mass. Okay, all the molar masses for carbon, hydrogen, and oxygen. There you go for your empirical formulas, molar mass. Okay, all right, settle. So this one is ready. Okay, the problem now is to find the molar mass of the compound ataupun molar mass of the molecular formula. Okay, the molar mass of the molecular formula ataupun molar mass of a compound, of that particular compound lah, in this case the organic acid. Okay, that is why this information is given here. Okay, that is why this information is given here. So this could be used as our conversion factor for our dimensional analysis. Okay, because we have two information there. 0.05 mole of this acid has a mass of 5.8 gram. Okay, all right. So any information that is given in the question may be used as our conversion factor. Okay, as you can see, we have two information there. So it can be used as our fractional conversion factor. Okay, all right. Yeah. Okay, because we want to find the molar mass of the compound. All right. Okay. Okay, if I were to use the dimensional analysis, okay, molar mass, remember molar mass stands for mass for 1 mole of a compound. That is what molar mass mean. Okay, so what we have here is this is the information which is given in the form of mole and gram. Okay, remember what we want. We want the final value to be in gram. Kenapa nak dalam gram? Because we want molar mass kan? Molar mass kan in gram. Mass for 1 mole of substance. Okay, so gram of organic acid. We want this. Okay, it need to be in gram. Therefore, how do we arrange the information? So if you want it to be in gram later on, so dekat atas should be gram lah. Okay, alright. So it should be gram. So gram 5.080 gram. Bawah at the bottom should be 0.05 mole. Okay, alright. So it should be gram. Later it should be gram. So what should be put here? Okay, what should be put here? So from the unit here, it should be the same as what we have here. Betul tak? So mole dekat sini, sini pun kena mole. Okay, alright. So what we want is the mass. Okay, what we want is the mass for 1 mole. Therefore, this is 1 mole. Betul tak? 1 mole tu kita nak tahu the mass of the organic acid. So here should be 1 mole. Even though it is not given in the question, but we will be able to know lah, because what we are looking for, molar mass. Molar mass is a mass for 1 mole. So this will be cancelled out and then we will end up with the molar mass of the acid. Okay, which is 116 gram. Okay, 116 gram of organic acid. Okay, this is for 1 mole. So we have that already. We can insert. Okay, we can insert into the formula. Okay, we can insert into the formula. Okay, and then we can solve for that. We got N is equal to 4. Okay, gram per mole will be cancelled out. This is not all. Okay, not all calculation will be using dimensional analysis. Okay, there are like formulas like to find the value of N ataupun the molarity later on. Okay, so for that, what I'm trying to say is that not all calculation will involve dimensional analysis, such as this N. Okay, so N we need to use this formula, molar mass of compound over molar mass of empirical formula. Okay, tak silap saya lah. So far kita memang tak guna untuk ni. Straightforward insert into the formula. Okay, is it? Yeah. Okay, alright. So gram per mole. So there should be no unit for the N. Okay, and then we multiply with just now CHO. N is equal to 4. The molecular formula should be C4H4O4. Okay, alright. So there you go for your molecular formula. Okay, all right. So we have two checkpoints here. So let's just go through the question very quickly. Okay, before we go to the next slide. Okay, let's look at the question. Question 1. Methyl salicylate has a mass percent composition of carbon, oxygen, and hydrogen. So all the masses in percentage are given. Okay, so the mass of one molecule of the compound is 2.53 times 10 to the power of negative 22 gram. As you can see, this is an extra information given. Okay, let's look at the question. Determine the empirical formula and molecular of the compound. So there are two questions similar to the one that we have earlier. Okay, there are two questions. So no wonder the information, extra information is given. This is to find the molecular formula. Okay, from the information given. Okay, from the information given, it is given in form one molecule. Okay, the mass is equal to 2.53 times 10 to the power of negative 22 gram. Okay, all right. So how can we use this in order to find the molar mass of the compound? Okay, the molar mass of the formula molecule ataupun molar mass of the compound is actually the same thing. Okay, all right. So we want the, okay, you can imagine. So this would be your conversion factor here, and this will be your final answer. It should be in gram, okay, because we are looking for molar mass. All right. So which one should be put at the top? Which one should be put at the bottom? Okay. So based on this, okay, the gram should be at the top, 2.53 times 10 to the power of negative 22 gram. Okay, so here, ini dia punya pasangan dia, jangan pergi ubah. So ini pasangan dia. If gram is at the top, therefore one molecule should be at the bottom. One molecule should be at the bottom. For one molecule, this is the mass. Okay, this information is given from the question. Okay, so kita ada darab kan? Okay, so kalau kat sini molecule, here should be molecule as well, right? So it should be molecule as well. Okay, so now what is the value that need to be put here? Remember, we want it to be in 1 mole. The mass should be for 1 mole. If it's molecule, what is the number that represent? What is the number of molecule that represent 1 mole? What is the? Yes, it is a number Avogadro constant. It is Avogadro's constant. So it should be 6.022 times 10 to the power of 23 molecules. Okay, anything that represent 1 mole, because we want molar mass. Okay, all right. So molecule can be cancelled out. Molecule, so kita times, so it will end up with gram. Okay, you have the mass already. That would be your molar mass. Okay, alright. So dia lain-lain. Tadi dia bagi mole and gram. This time around dia bagi molecule and gram. Okay, look at question number 2. It is slightly different because the mass is already given in a form of gram. Okay, but okay, a sample of isobutene consists of carbon and hydrogen, but only the mass of carbon is given. Okay, but not for hydrogen. It's not a problem because the mass, the total mass, the sample, the mass of the sample is given. So we can just simply minus the mass of the total minus with carbon, and then we get for we will have the mass of hydrogen. Okay, all right. So and then proceed the same way as what we have earlier for the empirical formula. Okay, now for the molecular formula. Okay, let's look at what are the information given. So this is the information given. As you can see, still dengan mole, still dengan gram. Okay, still with grams, but we need the gram in order to find our molar mass. Okay, all right. So, but this time around, it is given in a form of mole. Okay, this is similar to this one. Yep, it is similar to our example. Okay, you need to find the mole for one mole of. You need to find the mass for one mole. Okay, all right. So that's that. So that is the idea that you may be needed. Okay, when you are trying to solve this problem. Okay, all right. Do we have any question from the floor? Anybody before we proceed to the next topic?
No, madam.
No.
Okay, so far so good. Okay, all right,
So far
good.
so good.
All right, thank you for the response. Okay, next is combustion data. Okay, so combustion data is a common technique for analyzing compound. Okay, it is used to burn a known mass of compound and then weigh the amount of product made. Okay, so this is what I call an application to empirical and molecular formula. Just now, the one that we did for empirical formula is the simpler version. This is a little complicated, okay, a little bit complicated than the previous one. Okay, all right. So application of empirical formula. We have a compound. Okay, so basically it's the same. We want to know the number of constituent in the compound. Let's say we have C, H, and O. Okay, so the compound is consists of C, H, and O. So C is X, is unknown. H, Y, O is Z. Okay, so this need to be determined. Okay, so one of the method is by burning the compound. Okay, we burn the compound. Okay, when we burn the compound, we will produce product, right? Okay, we will produce product. Okay, from the product, we will weigh. Okay, we will weigh the product. Okay, to have the mass of the product. That is what it called. That is what it meant by this weigh the amount of product made. Okay, by knowing the masses of the product and composition constituent element in the product, okay, the original amount of constituent element can be determined. Okay, can be determined. So when we burn this product, okay, normally it will produce CO2 and H2O. Okay, and H2O. So apa nama tu? What we want is the individual of the constituents. Okay, individual mass of the constituent, which is for carbon, hydrogen, and oxygen. Unfortunately, what we have for the product is in the molecular state, in the molecular form. Dia dah combine. Kita nak in separate form, but the product give us in the form of molecular. Okay, dekat sini lah, this is the challenge. Okay, how do we separate the constituent from the molecule? Okay, previously you have given all the information in separate form. Senangnya hidup. Okay, dah ada carbon, we have carbon, hydrogen, oxygen in individual with their individual mass. Okay, tapi this time around you are given in molecular state. So how do we extract out, okay, the individual constituent? Carbon extract out from the carbon dioxide. Hydrogen is extracted out from H2O. So that later on we can calculate for the empirical. So at the beginning, okay, we have additional steps that need to be taken in order to calculate for empirical formula later on. Okay, all right. So once the masses of all constituent elements in the original compound have been determined, the empirical formula can be found. Okay, let's look at an example. So we have one example here. Okay, so combustion of 0.8233 gram sample of a compound containing carbon, hydrogen, and oxygen. Okay, so this compound, this sample will be burned, okay, and it produce products name CO2 and H2O. Okay, determine the empirical formula of the compound. As you can see, the individual mass for each constituent is not given. Dia tak bagi. Jadi kita kena cari. We have to calculate for each one of the constituent punya mass. Okay, so this is our our empirical formula, our expected empirical formula. So X, Y, and Z will be determined. Okay, all right. So what we can do is, even though it is given in a form of molecular form, we still can extract the carbon and hydrogen and later on oxygen. So the carbon, okay, the carbon can be extracted out from CO2, hydrogen can be extracted out from H2O. And then later on oxygen, we can just minus, okay, minus the compound, the original compound with the mass of carbon and hydrogen that we have determined earlier. Okay, all right. So, let's solve for carbon first. Okay, our mission is to find the mass of carbon. Okay, all right. So we have the mass of carbon dioxide just now. Okay, we have the mass of carbon dioxide just now. So find the mole. Okay, so find the mole. So we have the mole of carbon dioxide. Next would be the relationship. So how do we introduce the carbon? Okay, all right. So what is the relationship between carbon and carbon dioxide? All right. Okay. So we know that for 1 mole of carbon dioxide, okay, there is 1 mole of carbon atom. Okay, so we are talking about mole, okay? We are not talking about molecule. Okay, if I were to use molecule lah, for example, okay, imagine a molecule of carbon dioxide that consists of, so this is COO, okay, for 1 molecule. For 1 molecule of CO2, there is 1 carbon atom. Okay, 1 molecule of carbon dioxide has 1 carbon atom. So of course we are not dealing with molecules. We are dealing with millions, billions of molecules, right? So like number Avogadro tu, berapa banyak dia punya for 1 mole kan? Alright, so to correlate the molecule with mole. Mole maksudnya in the penjodoh bilangan lah, okay? Mole is not the same as molecule, okay? Mole is the penjodoh bilangan. Molecule is the entities. Okay, the entities itself. Okay, for 1 mole of CO2, by right, it should be 1 mole of carbon atom lah. Okay, janganlah 1 mole of CO2 molecule, there is 1 carbon atom. Is it logical? Logik ke? Dalam 1 mole carbon dioxide molecule tu, there is only 1 carbon atom. Okay?
Tak logik.
Tak logik langsung. Mesti dia kena tally. There should be mole and here should be mole. If you are talking about molecule, then you may refer it as atom. Okay, for the carbon. Okay, so that is the relationship that we have so far. Alright, so earlier on we have this is the relationship. Okay, so earlier on for carbon dioxide just now we have 0.0557 mole CO2. Therefore, the number of mole for carbon will be the same. Okay, because it is 1-to-1 ratio. Alright, okay, so next we have the mole of the carbon ready. Now we need to find the mass. Okay, so by using conventional method, you will multiply it with the molar mass. Mole cancel, okay, mole, the unit mole will be cancelled out and then you will end up with gram of carbon. We are done with carbon. Okay, so the mass of the carbon is now ready. Next, let's move on to hydrogen. Okay, misi mencari hydrogen pula. Okay, find the mass, the mole of H2O. Next, okay, the relationship for 1 molecule of H2O. If I were to use this example just now, for 1 molecule of H2O, there are two hydrogen atoms. Okay, that is only for 1 molecule. If If it is for 1 mole, therefore, okay, 1 mole of H2O, okay, should consist of 2 mole of hydrogen atoms. Okay, hydrogen atom. So by using this understanding, okay, alright, so we have the mole of H2O already. Okay, that means dia kena times dengan 2. The mole of hydrogen atom should be multiplied with a factor of 2. As you can see, ini pun buat saya geram juga ni. Okay, tidak ada unit, there's no unit, then suddenly the unit appears. Okay, so there should be unit dekat sini. Okay, later on, I'll show you how to use dimensional analysis to solve this problem. Okay, alright. Yep, and then find out. Okay, you have the mole for the hydrogen already. Now you can convert into mass. Okay, by multiplying with a molar mass. So mole cancel out. We will have gram of hydrogen. Okay, alright. So now let's move on to oxygen. So we have the carbon, hydrogen. Next will be oxygen. Okay, for oxygen, what we need to do is just to minus the mass of the compound, okay, with the mass of carbon, with the total mass of carbon and hydrogen. Okay, so there you go for your oxygen. Okay, we cannot use the method that we use for hydrogen and carbon just now to find the mass of oxygen. Why is that so? Okay, PK kan, during tutorial I'll be asking the question. Okay, alright. Kenapa? Why can we use the same method that we have for carbon and hydrogen? Okay, cara yang sama, 1 mole of carbon dioxide has 1 mole of carbon. Why can't we apply the same method in order to find oxygen? Kenapa? So fikir kan, kenapa tak sesuai guna cara itu? Bukan alternatif ada cara tu no. It cannot be used. That method cannot be used for oxygen. Okay, find out why is that so. Okay, next. Okay, so we have all the masses ready. So now we can insert all the masses into the table and then proceed the same way as what we have earlier. Okay, dia punya leceh part is at the beginning lah. We have to find out the mass for each carbon, each constituent. Okay, alright. Don't forget the empirical formula. So ni cut short agaknya. Okay, dia terus je mole ratio because the mole has been calculated just now kan. So dia terus masuk dalam bentuk mole sahaja. Okay, kalau you nak start from the beginning, it's not a problem. Go ahead. Okay, at the end, you must make sure that you write the empirical formula. Okay, so very quickly, let me show you how to use. Okay, let's use another color, green. Okay, how to use dimensional analysis, okay, for this problem. Okay, sama juga, misi mencari carbon first. Okay, let's start with carbon first. Alright, so what we have been given is this mass of carbon dioxide. So let's start with the mass of carbon dioxide, 2.445 gram carbon dioxide. This is given to us. Okay, alright, buat multiply and then our conversion factor. Okay, so we have gram carbon dioxide here, so gram carbon dioxide here. So what need to be put here? What is the mass that we need to use for this gram carbon dioxide? Somebody? Anyone, please?
1 gram.
Gram. For the gram. Gram carbon dioxide. So far, what we have learned earlier, 1 mole is equal to 1 mole is equal to ini. So
molar mass.
Sorry?
Molar mass.
Yes, the molar mass of carbon dioxide. Okay, because we have the unit already there. Okay, it should not be changed to mole because the reason we put gram is based on this here. Okay, alright. So it should be the molar mass of carbon dioxide lah. In this case, it should be 44 gram carbon dioxide. If this is molar mass, that means at the top should be 1 mole. Okay. So dia mesti ada correlation atas dan bawah tu. Jangan 44 gram and then suddenly atas ni 2 mole. Suddenly atas ni number Avogadros. Kan tak ada kena-mengena kan. You dah advance nanti somehow you can play around. Okay. But for now you are an amateur. Okay. Kita start macam beginners punya style lah. Okay. Alright. So kita very structuredly kita buat satu-satu dulu. Okay, 44 gram carbon dioxide, 1 mole CO2. That is the relationship that we have so far, kan? Alright, so now, gram carbon dioxide cancel out with gram carbon dioxide, and then kita carry forward this one dekat bawah. So that will be our guide. Okay, dia akan guide kita. Okay, kat bawah should be mole CO2. Okay, this is the time for you to introduce carbon. You should know, okay, what you have at the beginning and what you want at the end. Okay, you have the gram of carbon dioxide, but you want the mass ataupun the gram of carbon. Okay, when is the time for us to introduce the carbon? Nak introduce carbon, regardless lah mole ke apa ke, kita kena introduce carbon dulu. So that is the relationship just now. 1 mole of carbon dioxide has 1 mole of carbon atom. Okay, 1 mole of carbon dioxide, okay, has 1 mole of carbon atom. That's why kena tahu you nak apa. Okay, alright. So ini betul. This relationship still correct. Kita bukan mengada-adakan something. Okay, so mole carbon dioxide, mole carbon dioxide. So this is only in a form of in mole form. Okay, what we want is in mass. Okay, just 1 more conversion factor. Okay, here is mole carbon atom, bawah pun mole carbon atom. Okay, nampak tak dia punya unit tu cantik, kita carry. Okay, alright. So mole carbon. What we want is the mass of carbon, kan? So this is the time for you to introduce the molar mass of carbon. Okay, alright. So 1 mole of carbon atom, the mass is equal to 12.0 gram of carbon. Okay, this one will be cancelled out, this one will be cancelled out, and then you will end up with this one. Nampak tak betapa cantiknya tersusun, okay, the working. Okay, unit pun kita carry. Okay, memang kita akan carry sebab dia dah tertulis dekat situ. We will carry the unit. Sebab because of the unit, it allow us to cancel off. Without the unit, you nak cancel off apa? Nak buat macam mana ni? Semua nombor je macam ni. Okay, alright. So that is for carbon. So the same way we apply for hydrogen. Okay, alright. So let's say very quickly, hydrogen will be so mana tadi hydrogen? Nak cari hydrogen kan? So this is the mass of H2O. 0.06003 gram H2O. Okay, below should be gram of H2O. So what would be the gram? It will be the molar mass, 18. Okay, and then it should be 1 mole of H2O. So this one will be cancelled out. Okay, so we have mole. Okay, next, mole. Okay, at the bottom should be mole H2O. This is the time for you to introduce the hydrogen. Okay, in 1 mole of H2O, there are 2 mole hydrogen atom. Okay, just 1 more of conversion factor. So it will be this one cancel out, mole of hydrogen atom. Okay, so nak introduce mass kan. So 1 mole of hydrogen atom, okay, is equal to the mass, 1.0 gram hydrogen atom. Okay, so cancel out. You will end up with gram of hydrogen atom, which is 0.0667 gram. Okay, there you go for your hydrogen. And then next will be oxygen, samalah macam ni, tolak saja kan. And then proceed to your empirical formula determination. Okay, alright. Any questions so far, guys?
Madam,
Ya.
I nak tanya yang for the jalan kira tu, kiranya dia macam menggantikan ayat-ayat yang panjang tu ya? Kiranya kalau kita buat jalan kira yang potong-potong macam Madam buat tadi, ayat yang panjang-panjang tu tak payah buat?
Tak payah.
Oh, okay.
What the most important thing if we are using dimensional analysis is to have the relationship ataupun that relationship. Mana tadi saya punya ni? Aduh, hang pula lah. Yelah, hilang. Aduh, dia hilang. The conversion factor, the most important thing about dimensional analysis is the conversion factor. So the conversion factor is the relationship that we have beforehand, before we can proceed with the calculation. So what are the relationship that we have so far? Okay, so far that we have learned 1 mole is equal to Avogadro's, 1 mole is equal to molar mass. Those are our conversion factor. It can be manipulated atas bawah. Dia tak semestinya duduk bawah aja mole tu. Not necessarily. It depends on whatever unit that we have at the beginning. Okay, it can be manipulated up ataupun down. Okay, denominator or numerator. So itu je yang you perlukan. The conversion factor can be in the form of the information that we had beforehand ataupun the information that is given in the question, like what we have here. So this information is given in the question. Bukan yang ni. This is also, okay, it can also be used as our conversion factor. Tapi we are not using this lah. Okay, later on kalau ada soalan susulan ke kan, like this one just now. This is also our conversion factor. Can be used as our conversion factor. Information given in the question. Okay? Alright, saya tahu ada masalah. Yelah, baru kan. So, practice. Okay? You have learned using the conventional way in school. Okay? So, this is the updated version. So, you have to practice a lot so that you get familiar with it. So far, based on previous experience, okay, your seniors last time, okay, they were also reluctant at first. Tapi last time saya wajib kan. I make it compulsory for everyone to use the dimensional method. Okay, so saya akan check. I'll give practices and then if they have problem, they can consult anytime with me to check their working. So practice later on, they agreed with me. Okay, kata yang, yeah madam, it is much better than using the conventional method. It gives us hint sebenarnya. Dia bagi kita hint sebenarnya. Okay? Alright, any other question guys? Oh, okay, dah. I think there's no question for now. Okay, now it's 10:59 already. Okay, that's all for today guys. Thank you for your attention and Assalamualaikum. Bye.
Thank you, madam.
Thank you, madam.
Okay.
Thank you, madam.
Thank you, madam.